As the question says, a uniform chain of length L and mass M overhangs a horizontal table with its 2/3 part on the table. The friction coefficient between the table and the chain is mu. Find the work done by the friction during the period the chain slips off the table. So what's happening in this question is that there is a table on which a chain has been kept whose 1/3 part is actually lying vertically while 2/3 part is on the table. Now let us generalize this case and let us take the situation when x part is lying over this table. This is 2/3L, this is 1/3L. So let us take that x is lying, x length is actually lying over here. Okay, then we are having L minus x over vertical, right? Now they have asked us the work done by the friction during the period chain slips off the table. It is actually slipping, right? It has to slip down. We need to find out the work done by this table. If we can somehow manage to find the work done by the friction over a particular element, a small element, then we can integrate that over the length, that is this one, to get the total work done, right? So let us work with this generalized case when only x length. Note that this we have taken a case at an instant. Now if we take the element to be dx, that is the length is just dx, then dw1, that is the work done by the friction, will be mu n, and the distance will be x because this is x. Because what is work done? It is force into displacement. What will be the displacement? At this instant, it will be x. Because x part is lying above the table. In order to slip off, it has to move x distance. Right? So the distance is x. And this is simply mu m element into g x. Now what is the mass of this element? Like this. Mass of the element is mass per unit length, that is m by L, into the length of the element itself. Putting this back into this equation, we get that dw1 is simply mu m by L dx g into x. Now what will be the total work done? It will be the integral of dw1. So it changes to the integral on both the sides. So we will be integrating, that is the work done will be integral of mu m by L dx gx from 2L by 3 to 0. Note the x was the length of the part lying above table. At the initial moment it was 2/3L. But finally it will be 0 because it will slip down. So the limits will be like that only. Don't exchange these limits. Right? Now integrating this, we get it as 2 mu mgl over 9.